We're seeing a really fundamental shift in how we create our built environment. The idea of a traditional construction site is starting to evolve into something more like industrialized manufacturing, where our buildings are assembled with incredible precision, not just built piece by piece on site. Let's take a closer look at how this actually works.
So, to start, it's really important that we update our understanding of what factory built actually means today. We're not talking about the temporary, lower quality prefabs you might be thinking of from the past. The modern approach is, well, it's in a completely different league, both structurally and technologically.
At the heart of all this is something called permanent modular construction, or PMC. Basically, it's a process where entire three-dimensional sections of a building, modules, are manufactured indoors. And these are not temporary structures. They're built with the exact same high-grade materials like steel, concrete, and timber that you'd find in any conventional building, but they have the huge advantage of being built with the quality control of an assembly line. This really gets to the core philosophical change here. Construction is moving away from being a unique, one-off project every single time, and it's becoming more of a productized system. And that shift puts the focus on precision, on repeatability, and on maintaining a digital thread from the initial design all the way through to the final assembly. So how does this process actually play out? The best way to think about it is as an optimized multi-stage workflow that runs on a completely different timeline than what we're used to seeing at a typical construction site. The process breaks down into 4 main stages. It all kicks off with a really intensive digital design phase. Then the workflow splits in 2. While the building modules are being manufactured in the factory, the on-site foundation and prep work are happening at the exact same time. This parallel activity is the real key to its efficiency, and it all comes together in the final on-site assembly. And that controlled factory environment allows for a level of oversight that's, well, it's pretty much impossible to achieve outdoors. Think about it. Plumbing and electrical systems can be fully pressure tested and certified before the walls are even closed up. It's a much more proactive way of ensuring quality. This industrialized workflow leads to some very real data-driven advantages. Let's look at 2 of the biggest ones: the major gains in project speed and the incredible increase in structural precision. So by building the structure in a factory while you're simultaneously getting the site ready, the total project schedule can be shortened by 30, even 50%. And what that means is that buildings can be occupied and start generating value much, much sooner. This really highlights the difference in precision. On a traditional site, tolerances can vary a lot because of weather, human factors, you name it. But in a factory, components are cut by computer-controlled machinery with sub-millimeter accuracy. That ensures a near-perfect fit and alignment when the modules are finally stacked together on site. Now, underneath this entire system, you have some pretty sophisticated digital technologies and a different kind of financial structure. And understanding these 2 things is really crucial to seeing why this model is not only viable, but what its requirements are. At the very heart of the process is the digital twin. It's a complete virtual model of the building, usually created with tools like Building Information Modeling, or BIM. This digital twin lets engineers and architects test every single component for clashes and fit, all before any physical material gets cut. As you can imagine, that drastically reduces errors and waste down the line. The financial profile is also quite different. As you can see here, the initial capital deposit is higher. We're talking 30 to 50% because all the materials are bought right at the beginning. But that investment is balanced out by a much shorter construction period and a really dramatic drop in material waste, from as high as 15% down to less than 2%. So you're de-risking the project by locking in your costs and timeline very early on. Okay, so let's zoom out a bit and consider how this approach helps build a more sustainable future. The efficiency baked into the modular process has some really significant positive effects on the environmental impact of construction. To really get the opportunity here, we have to look at the context. The conventional construction industry is responsible for up to 40% of all global waste, and it accounts for nearly 1/3 of global CO2 emissions. These numbers really highlight just how urgently we need a more efficient model. Factory-built construction tackles this head-on. Material offcuts are all managed and recycled in one central place. Logistics are optimized, which means far fewer truck trips to the job site. And maybe the most interesting part is that buildings can be designed for disassembly. That means modules can be relocated and reused later on, which is a core idea of a circular economy.
And, this isn't some theoretical concept for the future. It's being deployed right now on some of the world's most ambitious urban development projects. Nations are using industrialized construction to meet massive housing and infrastructure demands at a speed that just wasn't possible before, especially in places with really rapid urban growth.
So this brings us to a really crucial question. As our cities keep growing, as they face this immense pressure for new housing and new infrastructure, maybe the shift toward manufacturing our buildings isn't just an alternative, but the most logical, scalable path forward. It represents a more predictable, more efficient, and more sustainable way to build the cities of the future.